Good evening, everyone. This is January 2016, Unit 2 of IAL Chemistry. So, in the first question, which of these molecules is polar? So, how we can work out if the molecule is having a polar bond and it is asymmetrical, then it will be a polar molecule. When we check carbon dioxide, the structure of carbon dioxide or CO2, it is a linear structure. So, even though the bonds are polar, but because it's a symmetrical linear structure, that's why overall molecule will be a non-polar. Same way, when we check NH3 ammonia, there are 3 bond pairs and 1 lone pair. So because of this lone pair, overall molecule is not symmetrical. That's why bonds are polar, because nitrogen is more electronegative, so partial negative, hydrogen is partial positive. So B will be the right answer. Why not C or D? Because carbon tetrachloride, identical bonds are there, symmetry is there in the structure. That's why the molecule will be a non-polar. Even though the bonds are polar, but the molecule will be a non-polar. In question 2, which of these species has a bond angle equal to 90? So bond angle equal to 90, when we draw the structure, beryllium tetrafluoride. So with the charge -2 is there. So Be having 2 electrons and 2 extra electrons are there. That's why the overall charge is -2. So when we draw the structure, there are 4 bond pairs and there is no lone pair. So when we have 4 bond pair and no lone pair on the central atom, so it means it will be a tetrahedral, so it cannot be A. Same thing, silicon tetrafluoride. When we draw the structure, silicon belongs to group 4, so it will have 4 electrons and bonded share 1 electron in each chlorine. So the central atom is having 4 bond pair and there is no lone pair. That's why it cannot be B. NH4, nitrogen having 5 electron, 3 it will share with hydrogen first, and then there is a dative bond. So it appears to be 4 bond pair. When 4 bond pairs are there, then it will be a tetrahedral structure with a bond angle of 109.5. When we draw SF6, sulfur hexafluoride. So sulfur belongs to group 6 and it is sharing 6 electrons here. Because of the empty d orbital, it can share more than 8 electrons. So fluorine are bonded. I'm just drawing the bonded electron of fluorine. So 6 bond pairs are there and no lone pair. It means the bond angle will be 90. This bond angles will be 90. That's why D is the right answer. For question 3, which of these species does not have a trigonal pyramidal shape? To be trigonal pyramidal shape, in trigonal pyramidal shape, there should be 1 lone pair and 3 bond pairs. So when we draw the structure of BF3, boron bonded with 3 fluorine, so 3 bond pair and there is no lone pair, so it will be trigonal but not trigonal pyramidal. What about others, B, C and D? Because ammonia is there, so 3 bond pairs, nitrogen forms 3 bond with hydrogen and 1 lone pair. In hydroxoniamine, oxygen is forming 3 bonds and 1 lone pair is there. It will be trigonal pyramidal. Same thing, phosphorus hydride. three bond pair and one lone pair, it will be trigonal pyramidal. So A is the right answer, which is a trigonal structure with a bond angle of 120 degrees, because each there is no lone pair and boron bonded share one electron with each fluorine. Question 4. Which of the following molecule has the greatest number of lone pair of electrons? So how we can work out the lone pair of electrons? Carbon belongs to group 4, so it will share all 4 electrons to complete octet. Hydrogen will share 1, and oxygen will share 2, belongs to group 6, share 2, and 2 lone pairs will be there. So the first one, there are 2 lone pair. Then chlorine belongs to group 7, so it will share 1, and there will be 3 lone pairs. Nitrogen belongs to group 5, so it will share 3, and there will be only 1 lone pair. And oxygen, again, there are 2 lone pairs. So which is having the highest number of lone pair? B is the right answer. Which diagram represents the square planar structure? So square planar structure, as you can see clearly here, we have 3 bond pairs and we have 4 bond pairs and 2 lone pairs. So when we draw SF4, so in SF4, sulfur belongs to group 6. So it is sharing 4, so there will be 1 lone pair. 4 bond pair, 1 lone pair. So this cannot be SF4. In NH4, is one of the bond is dative, so all 4 bond pairs are there. There is no lone pair, so it cannot be NH4. Xenon tetrafluoride. So xenon belongs to group 8. It share 4 electrons. And how many are left? Because 1, 2, 3, 4, 5, 6, 7, 8. So there are 4 bond pairs and there are 2 lone pair. So it will be XFE, XeF4. Same way, it cannot be aluminum hydride, because aluminum extra charge electron is there and bonded with hydrogen, share 1. So 4 bond pair and there is no lone pair. That's why C is the right answer for this. Which of the following compound has hydrogen bonding in a liquid state? The hydrogen bonding occur when hydrogen bonded with the most electronegative elements such as fluorine, nitrogen, and oxygen. So only these 3 elements, when hydrogen is directly bonded and there is a lone pair on these electron in these elements, then it will be a hydrogen bond. So this cannot have a hydrogen bond because hydrogen is not bonded with any of them. So D is the right answer, ammonia. Question 7. Which of the following element has the greatest attraction of bond pair in a covalent? So in a covalent structure which is having beryllium and boron group 2 and 3, so they don't have a covalent structure, we are left with C and D. When we check, chlorine is having 3 shells, first shell 2 electrons, second shell 8, third shell 7, and same thing for another chlorine, first, second, and third. So the distance from the nucleus, the shared electron, the distance is minimum, so it will have a greatest attraction. That's why D is the right answer. In question 8, in a molecule of hydrogen, 2 hydrogen atoms are held together. So how the 2 hydrogen are held together? When hydrogen forming a bond with another hydrogen. So there is a covalent bond. So it's not a hydrogen bond, it's not a polar, because identical bond attract tendency to attract the shared pair of electrons. It's a non-polar covalent bond. It's not a London forces, because these are intermolecular forces. But they're in the question they are asking about intramolecular, because in a molecule of hydrogen, 2 hydrogen atoms so held together. That's an intramolecular force. So intramolecular can be an electrostatic force of attraction between the charges, between the positive ion and electron, and between the nucleus and the shared pair of electron. Which of these metal give a lilac color? Potassium. So lilac is due to potassium. That's why B is a right answer. In question 10, 100 cm cube of a solution of 0.5 mole per dm cube silver nitrate is reacted completely with excess of calcium chloride. The maximum mass of the precipitate. So first, you should write the balance equation to work out the mass of the precipitate. So we have silver nitrate that is reacting with calcium chloride. This will result in a formation of precipitate, white PPT of silver chloride, and calcium nitrate is the aqueous. So it should be balanced if I put 2 here and 2. The equation is balanced. This one is an excess reagent. So we always work out from limiting reagent. So how we can work out the mass of the precipitate? 100 cm cube and concentration and volume. So first we'll find the moles of silver nitrate. That is concentration into volume. The concentration is given 0.5 and the volume is 100 divided by 1000. So this will be 0.05. These are the moles. And using a moles of silver nitrate, we'll get the moles of silver chloride. The ratio is 2 is to 2, or we can say 1 is to 1. So we'll get the same number of moles. That is 0.05 moles of silver chloride will be there. But we need the mass of the precipitate. So to get the mass, moles equal mass in gram over molar mass. So mass in gram is equals to moles multiplied by molar mass. Moles 0.05 multiplied by molar mass. Chlorine is 35.5 plus silver Ag. So we'll use the periodic table which is given at the last. So silver is 107.9. So this will be 107.9. So 0.05 multiplied by 107.9 plus 35.1. So you'll get 7.17 grams of this precipitate. What volume of 0.2 mole per dm cube potassium sulfate solution is required by diluting with water? 1 mole, 1 dm cube of a solution with potassium ion concentration 0.1. So first we'll find how many moles of potassium ions we need. So we have the volume and concentration. So moles equal, concentration is moles over volume. So moles equal concentration into volume. This will give moles of potassium ion. So concentration that's given 0.1 and the volume we need 1. So the moles will be 0.1 dmq. 0.1 mole. These are the moles of potassium ion. But we need the volume of potassium sulfate solution. So how many moles of potassium sulfate should be there? How we can work out? As we know, the potassium ion, 2 moles of potassium ion react with 1 mole of sulfate ion. This will result in a formation of 1 mole of potassium sulfate. So ratio is 2 is to 1. So if we have 0.1, this will be x cross multiply. So this will be 0.05. So these are the moles of potassium sulfate which we need. We have the concentration, we have the moles, so we can find the volume. The concentration is moles over volume, or volume is moles divided by concentration. Moles, that is 0.05 divided by 0.2, so that will be equal to 0.25 dm cube, but we will convert multiply by 1000, so it will be 250 cm cube. So B is the right answer. What is the volume of dilute sulfuric acid concentration 0.02. So we have C1, V1 is required. Neutralize 20 cm cube, so that is V2, and concentration is 0.01. So C1, whenever acid-base reaction, C1 V1 over N1 equals C2 V2 over N2. One side you can take for acid, and another side you can take it for alkali. So concentration of acid, that is 0.025. Volume of acid we don't know. The number of moles of acid from equation N1, and this is N2, which is 2. This is 1. Concentration is 0.01 multiplied by volume is 20 and divided by 2. So when we solve for V1, it will come out as 4 cm cube, or A is the right answer. The chlorate 1 ion is formed when chlorine dissolves in water. The concentration of chlorate ion increase by, so how, we want to increase this concentration, so means we want this reversible reaction to shift towards right hand side. So if we add potassium hydroxide or OH, so when that OH will react with H, amount of hydrogen ion in the solution decrease, so equilibrium will shift towards right. That's why A is the right answer. If you add hydrochloric acid, it will increase the amount of hydrogen ion, so equilibrium will shift towards left hand side. If you add solid sodium chloride, amount of chloride ion increase, equilibrium shift towards left hand side. If you add potassium sulfate, so this potassium sulfate does not have any effect because none of the reagent is reacting, either reactant product is reacting with potassium or sulfate ion. When a solution of iodine is titrated with aqueous sodium thiosulfate, the thiosulfate ions are oxidized too. So the balance equation, when iodine is reduced and thiosulfate ions are oxidized, so it will form 2 iodide ion and it will form S4O6 with a charge 2 minus. So thiosulfate ions are oxidized to S4O6 with a charge 2 minus. Which trend are correct in group 2 in descending? Solubility of sulfate, as we go down it decreases, and for hydroxide it increases. So B is the right answer. Which is tertiary halogen alkane? So tertiary halogen alkane, compound in which carbon bonded with a functional group or alkyl groups are there, that will be tertiary. So when we draw this CBr, CH3, 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 so this is a tertiary halogen alkane. Propene can be formed by heating 1-bromopropane with alcohol in like potassium hydroxide solution. So the reaction is elimination reaction. So that's why C is the right answer. If it was done in aqueous medium, then it will be nucleophilic substitution reaction. A simplified mass spectrum of organic compound is shown. Which of the following compound produces this spectrum? So here the molecular ion peak, this is 55, 56, 57 and 58. So we just have to check which one is having a molecular formula of 58. Propane, it will be C3 and H8, so it will be 12 multiplied by 3, 36 plus 8, that is equals to 44. So this cannot be propane. Propane 1 all or propane 2 all, they will have the same molecular mass, different, these are isomers. So C3H7OH. So it will be 12 multiplied by 3 plus 8 plus 16. So 36 plus 8, 44, and 44 plus 16, that equals to 60. So it cannot be B or C. So it is propanol. And what is propanol? It is CH3CO, CH3. So 36, because 12 multiplied by 3, that's 36, plus oxygen is 16. plus hydrogen is 6. So this will be 36. That's propanol. C double bonded with O. So 12 multiplied by 336 plus oxygen is 16 plus hydrogen. There are 6 hydrogens, so 36 plus 16, 42, and 42. So this will be 12 multiplied by 3, 36 plus 16, sorry, 52, and plus 6, that's 58. This will be D is the right answer of propanol. So question 19, a compound with empirical formula C3H6NO. So when we write the molecular formula of hexane 1,2-diol, if I draw the structure, hex means 6 carbon, and OH group with the first one and second. So when you count 1, 2, 3, 4, 5, 6, so C6 hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and oxygen 2. So when we further simplify, this will be C3H7 and O. So C3H7O, this cannot be A. So when we check for B, hexane 2 all. So C6H13 OH will be there, or C6H14O. So it cannot be further simplified, so it cannot be hexanon, hexane 2 on. This is CH3, CH2, 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 and CH3. So there are 6 carbon atoms, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and oxygen. So we cannot further simplify, so it cannot be. Then hexanoic acid. So when we draw hexanoic acid, CH2, 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 and CH3. So 1, 2, 3, 4, 5, 6. So C6, H3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and oxygen 2. So when we simplify C3, H6, and O, that's why D is the right answer. The last question, 20. Equal amount of 1-chlorobutane and 1-iodobutane are bound with nitric. Why does 1-chlorobutane react more slowly? Why it react more slowly? Because we have one chlorobutane and 1-iodobutane. And 1-chlorobutane, because the bond is stronger, that's why it will take time to break. That's why B is the right answer. So this was January 2016, Unit 2 of IAL Chemistry.